The components of the body involved in baroreceptor control of blood pressure include the brain, medulla oblongata, glossopharyngeal nerve, vagus nerve, carotid and aortic sinuses, the heart, and blood vessels throughout the entire body. The carotid and aortic sinuses contain baroreceptors which detect the stretch of blood vessels in each of those areas. When blood pressure in those areas falls above or below homeostasis, the receptors send signals through the glossopharyngeal and vagus nerve to the medulla oblongata, signaling for the blood vessels to dilate or constrict in order to change the blood pressure. The vasomotor center of the medulla oblongata analyzes this information sympathetically or parasympathetically and reacts. If blood pressure is too low, then the cardioacceleratory center sympathetically stimulates the glossopharyngeal nerve to secrete norepinephrine, resulting in an increased blood pressure and vasoconstriction. This occurs because the baroreceptors detect too much stretch in the carotid sinuses. On the contrary, if blood pressure is too high, then the cardioinhibitory center of the brain parasympathetically stimulates the vagus nerve, which secretes acetylcholine to decrease the heart rate. This occurs because the baroreceptors detect too little stretch in the carotid sinuses and aortic sinuses, resulting in vasodilation to decrease the heart rate. Additional factors that play an important role in blood pressure control include the sympathetic and parasympathetic tone. Each of these controls the heart rate by keeping it near 70 beats per minute parasympathetically or not allowing it to exceed 230 beats per minute sympathetically when the heart rate is increased. In doing so, these tones ensure that the heart efficiently pumps enough blood to feed the body with oxygen, which overall affects the blood pressure. The heart rate is the number of beats per minute. Other factors that are important in measuring and analyzing blood flow include the heart-stroke volume, which is the volume of blood being pumped out of the left ventricle to be distributed to the rest of the body. Another important measurement is cardiac output, which is calculated by multiplying the stroke volume times heart rate. This also tells us the amount of blood being pumped out of the heart into the body every minute. Each of these factors is important in order to recognize why the blood pressure is increasing or decreasing. Clinically, these measurements are taken into consideration in order to understand how efficiently the heart is supplying the body with blood. Blood traveling through blood vessels must also overcome total peripheral resistance of the cardiovascular system, which involves pressure that opposes blood flow, vessel length, and vessel diameter. These factors can depend on blood pressure and baroreceptor changes of blood pressure. If there is too much turbulence in the blood vessel due to high blood pressure or small diameter, then the heart may not be efficiently pumping blood throughout that area of the body. Additionally, the arterioles have the most control over peripheral resistance, which affect blood pressure due to the arterial diameter. Arterioles are the close vessels to the capillaries where gas exchange in tissues occurs. This concludes the description of baroreceptor control of blood pressure. Thank you for watching.